Hello. Good morning, everybody. Thanks for coming out. Today, we're going to talk about robots. Robots and Flutter and how we can control them over the internet. Let's see if I can figure out how. My mouse is over there. So, when I made my talk, I submitted it as, how do I do this? Oh, there it is. Okay. WebRTC, I should have included and gRPC on there. I thought that was an important little tidbit. We'll throw it in here, pretend like it was there the whole time, and we are good. So we live in an ever-evolving world. You all know this. You're software engineers, technology-minded folks. Things are constantly advancing around us. Not too long ago, your car dashboard probably looked something like this, and it was cool. It was really awesome to have that teeny tiny little LCD screen right there, the navigation. Nowadays, probably looks something like this. A lot more screens, a lot more sensors, a lot more touch points for the technology to know what's going on under the hood. When I was growing up, a lot of the thermostats looked like this. And to be honest, in my New York City apartment, some of them still do look like this. But many of you might have a very smart thermostat, something you can control from your phone, something that has a digital screen, something that's smart, connects to the internet. I think you get the idea. Nokia bricks, great old phone. Not that long ago, this was kind of the staple. Now we all have smartphones, iPhones, Androids, really advanced devices. So I don't need to tell you this. The world is advancing. There's more and more hardware around us. There's more and more robots, smart machines, smart home devices around us in the world. And I think we as software engineers have a really big opportunity to learn how to interact with these things and build really great interfaces so that, we can help advance technology and do cool things with hardware and stuff. So who am I? My name is Clint Purser. I'm the lead mobile engineer at a robotics platform called VM. We're based here in New York City. I joined VM about 2 years ago as the first mobile-minded software engineer, built some of our first SDKs that allowed you to build iOS and Android apps that talked with hardware. I actually, last year at Fluttercon, I was so inspired that I reached out to the previous organizers of Flutter NYC because they had given it up. And since then, I've been organizing Flutter NYC, which is one of the largest Flutter meetups in the world. Here I am. This is like 2 months after I started at VM, fresh in the city, and we hosted the meetup. There I am talking about the same thing I'm talking about today, except for we're a lot further along. We can do a lot more cool things with it. That was like, I had been there for 2 months. You get the idea. A few years later, here we are at the Flutter NYC meetup. This was earlier in January. I see some people who were in the room there. Thank you for coming. Super fun. Sometimes we get to host it at the Google offices here. This one, we had Eric, who's here somewhere in the crowd, chat about Flutter app architecture. It was a good time. It's a really good meetup group. Tons of really awesome people here in the city building cool things with Flutter. Okay, I have a question for the crowd. Think in your mind. You can close your eyes and think. And I've already talked to some of you, and I know you know what a robot is, but think in your mind, what is a robot? Do some of this. What is a robot? Okay. Can I get a volunteer? What's a robot? Who has one that they've thought of? I have swag. Raise your hand. I'll throw you something. A what? Bender? Okay, here, you get stress ball. Sorry. Oh, it went flying. I'm so sorry. He's good. Because when I thought of this, Bender is also on my list. So if you're like me, and this gentleman is, you might have thought of one of these characters from media. My kids love WALL-E. They do not love the Terminator. Or maybe you thought of some of these guys. These two of these are in fact not robots. They are people in suits or computer generation. The other one actually is they built a real robot that they used in a lot of the movie for that one. Or maybe you thought of something like this. Boston Dynamics comes to mind as, really advanced robotics. I kind of like have nightmares at night of like the videos of them like kicking those robots and pushing them over and then seeing them get back up. Or maybe you thought of one of these Tesla robots. More often than not, these are the kinds of robots, though, that are in the world. Car manufacturing in general has really like pushed forward automation, robotics, so forth. So like for a long time, this has been what's pushing it forward. We also use robots to go places that humans can't go, deep in the ocean, where the pressure is too much. This is a cool one, a robot that's building a house, 3D printing a house with cement, right? There's all sorts of robots beyond like the human autonomous robots that are actually doing like real things in the world today. Amazon's famous fleet of, factory, what's the word for the shipping facility robots to bring them the things so they can pick them. I also posit that smart home devices, IoT devices, are like light robots. And if you're building a robotics platform, which like as I'm working at a company that's a robotics platform, you find that you get IoT for free, kind of like along with it. It's like a robot with like one component and some software on top of it. So a lot of these robots that we've talked about have human interaction in the loop. I don't know if anybody saw this Tesla demo. It seemed really cool. I had like my neighbor in my apartment be like, is this real? Like, are robots really doing this? And I was like, maybe, but like they're probably being like operated. And turns out like they were, like they had people there like closely monitoring, like it was in a very tight loop. It's still very cool. And, maybe eventually we'll get to like really autonomous stuff, but more often than not, for really advanced robotics, they have teleoperation, which is humans controlling in the loop. Imagine if you were building a fleet of delivery robots. Maybe you've seen some of those. I know we have some in Jersey City here nearby that if you go on the Jersey City subreddit, people are always like freaking out about or like don't know what to do with it. Or Waymo, if anyone's been in the Bay Area or the various other cities they're in, these drive around. Imagine if you were building a fleet of thousands and thousands of these robots. Chances are they're going to get stuck, or their camera's going to get broken off, or they're going to get in a car accident on accident or something, and a human needs to step in temporarily, in this case, and fix it, get them back in a good state so then they can continue on. That's what we mean by teleoperation. If you ever heard that term with robotics, that's typically what it means in this sense. Historically, a lot of these technologies that have been used, Wi-Fi, internet, BLE, deep space network for like robotics on the edge, which makes me think if I were to build an app, I'm a mobile software engineer. I actually never touched hardware before I joined this company, and it's been a lot of fun since. But if I were to build an app that would talk to a robot, what protocols would I use? What technologies would I use to connect to it, to send it commands, to get information back from it? How would I approach that, right? And so the answer that we've come up with at VM, and this is a common thing actually, like we didn't invent it, but is WebRTC. Show of hands, who has heard of WebRTC before as a technology? Okay, we got some people. It's common. Okay, good, because as you know, it's usually pretty abstracted away from, like it's under the hood a bit, but I'm going to walk through it. We're going to do a little WebRTC 101, talk about why it's a good fit for robotics. WebRTC stands for Web Real-Time Communication. Let's see what I did here. Okay. Who has used Google Hangouts before? By show of hands. Okay. Zoom. Microsoft Teams. Discord, Skype, ChatGPT, the like little voice chat, Zoom. Wait, what's that one? Slack, BitTorrent. Okay, police, we got them. Police, they're in here. I saw your hands. I don't know. All these technologies use WebRTC in some form of another, especially when it is using, so like BitTorrent, for example, peer-to-peer streaming of data of files, right? All of these others typically have to do with real-time audio streaming or video chat streaming. That's where WebRTC comes into play. Let's talk about WebRTC a bit more. First introduced in 2011, and then the first, and then first version of it was built by Ericsson Labs. It wasn't until a couple years later when it was first used in Google Hangouts in like mid 2014. So that's kind of the time frame we're working with here. Mid 2014, some of the first uses of WebRTC. It's built as a tool typically for web apps to talk directly to each other. They create a peer connection and they just, talk directly. Before this, if you were to want to achieve a similar thing, and I know probably a lot of you have done a similar exercise where you want to build a chat, like a texting chat room, and you would use something like WebSockets, which puts a server in between, and then you're both pushing and pulling to that web server. You establish a connection to that. So that would be the same thing here, but there'd be a server in between. A lot of the times, you don't want that. You don't need that. That's a lot of infrastructure, and especially if you're streaming large things, a lot of information, you want a peer-to-peer connection. So WebRTC didn't really invent anything in of itself, very little if so. More so, it's a collection of many technologies, protocols that then together make it a very robust way to establish a peer-to-peer relationship. So in the base of it, it all works over IP, Internet Protocol, which makes it great to work on various platforms. From there, UDP, fire and forget, a lot faster than TCP. So it's built on a layer of that, which then brings us to a whole bunch of acronyms. And they're actually like acronyms within acronyms at that next yellow level there. Let's talk about that a bit more as we dive deeper into WebRTC. So STUN stands for Session Traversal for NAT. Again, acronym inside an acronym. Turn, traversal using relays around NAT. Interactive connectivity establishment, ICE. So we'll talk a bit more about what those means. NAT is network address translation, and what that is saying is when you have your phone or your laptop, you're not like connecting directly to the internet. You're going through your Wi-Fi modem, your gateway, and so in order to do a peer-to-peer connection, you need to map out that relationship on your local network. Most peer-to-peer connection that deal with NAT, they deal with it by doing some sort of hole punching through the network. So think like the Kool-Aid Man here. So how does WebRTC accomplish this? It does it through using stun servers. Essentially, when you ping a stun server, it's going to give you back your NAT. It's going to give you back like the mapping of what your network looks like so you can establish that. If for some reason the stun server doesn't work, you then use a turn server, which acts sort of as a relay. So this is a fallback. It's a last resort. The connection, if you end up using a turn server, is going to be slower. You're going to have higher latency, but it's a fallback. We're trying to build a robust WebRTC connection here, peer-to-peer connection. So that's a fallback, which then, and ICE, kind of relates to all of that. How ICE is the overarching, like when it calls those different things. Which then brings us to this next level, which is the media and data channels. There's a whole bunch of handshakes that happen here in DTLS and SRTP to establish those connections. Less important for the overall thing we're talking about here. No matter what kind of connection method you use, whether it's like stun or turn or whatever, you need a way that these two peers can initially send some information that then they can use to then establish that. So that's what a signaling server does. Now, WebRTC actually states that it doesn't care how you do signaling. It kind of exists outside of WebRTC. So you could do this a whole bunch of ways. It could be, there's demos online from WebRTC where it's just using a Firestore. And so they both hit a Firestore, sending their information, which is like, here's how to connect me, here's the information I'm going to send. And then they take that and then run through the rest of the process to connect with each other. So we've been talking about 2 web applications, but what if I want a robot as a peer? What does that mean? What does the robot have to do? Because before, I mean, this is like you're both hopping on a Zoom call, so you both kind of like call each other, right? You both initiate it. So the robot has to do something autonomously to signal like, hey, I'm here, I'm ready to connect. So let's walk through how you can do that, how we do it. We think this is a great way. So first, you have your robot, your application, the signaling server. The robot says, hey, I'm ready. As soon as it comes online, gets on the internet, pings this central server and says, I'm ready. Here's my connection information. So then later, when you have your application that you want to talk to the robot, you say, hey, I'm going to call this robot, and you hit that same server. You'll then exchange the information. Robot will know that it has a caller incoming. You'll get the information back that you need to then dial the robot, and then you establish that peer-to-peer connection. So that's what that looks like. Hey, we have a peer-to-peer connection. Let's go. Woo! Okay, so why WebRTC is good at this? It's really good at peer-to-peer direct connections, which is really important for a few reasons. If devices are constrained by firewalls or in various locations, say you're building a large fleet of robots and you don't have or like IoT devices, you don't know what people's home network firewalls are going to be like. You need ways to kind of like get around that hole punch through it, which if you were building like with WebSockets would be a bigger problem. Yeah, you want to bypass a central relay or a central cloud server. That's if WebRTC allows you to do that. And then if you're streaming high bandwidth things, high bandwidth sensor data like LiDAR, video, stuff like that, which when you're doing robotics, you want. So we're good to go, right? Well, we still got to figure out a few things. You sure about that? We have the WebRTC connection, but now what? What are we sending over the wire? WebRTC actually doesn't care also at this point. You could send strings, you could send JSON, you could send whatever you want. So I think best way to approach this, a really good technology is to use gRPC. You can use gRPC and protobufs to define what the messages you're going to send, generate the code for it in a bunch of different languages, and then be able to send that over the wire. It's also really great because you don't know if in all scenarios you're going to be using WebRTC. You might be using direct gRPC if you're on the same network. You might be using MDNS if you're on the same network. You might be using BLE, right? So if you establish these messages in protobuf, that gives you the ability to use it in all sorts of environments universally across like anywhere in your stack. So that's how we approached it at VM. And if you were building this on your own, you could do it this way too, which makes it possible so we can define a ARM API with ways that we think is best for controlling an ARM, or a camera component API, which has things like, get a video stream or get a single image, or, what you want from a camera. Also for like something like a computer vision service, we define all these protobuf messages, APIs for this, and then it allows us to define it in languages like Dart and for Flutter, Go, C++, Java, JavaScript, TypeScript, so on and so forth. Another really, great thing about this is we have this and just open sourced it. So all of these APIs are open source. You can look at them. Protobuf allows it to define it once and use it everywhere, kind of like Flutter. Okay, so why is gRPC really good? Low latency. It enables continuous bidirectional streams, which is really great. So you can send updates to like a robotic arm simultaneously while doing other things. Let's see about that. Did that show up? Yeah, cross-platform, multi-language consistency. I already kind of mentioned that. You get the idea. Lightweight, efficient serialization, really great when you want to send a lot of things over the wire. Protobuf does a great job at that. And then security benefits. gRPC, also WebRTC, establishing that peer-to-peer connection inherently has a lot of security baked into it for your robots. And then also, yeah, you can abstract out the services and the components you're building with these gRPC Protobuf messages. Okay, great. So back to this. Now, we feel like this is a pretty good approach, sending gRPC over WebRTC to the robot. But let's talk about the client now. Let's talk about why we're all really here. Flutter. Why is Flutter a really great fit for this kind of approach? Oh, that's so fun. I just realized the little square in the corner. Okay. Yeah, so why Flutter? Again, not the right crowd for this. Yeah, I don't need to talk you into this, but let's do it. Multi-platform support, iOS, Android, desktop, Linux, even TV platforms. We've got a few talks here. My boss has literally been like, hey, can we build like a Flutter app on an Apple TV to like, he wants to see like data from his robots on his Apple TV. Not that hard to do with Flutter, WebRTC, Protobuf. It all, just kind of works the same way. Hot reload, builds so fast, iterates so quickly. As a side note, my last company, we hadn't adopted Flutter yet. Like 10 minutes to build an app. I'm sure you've all been there at some point. I love hot reloads so much. Great community support. We're able to leverage the open source Flutter WebRTC and gRPC packages. Those are like our main dependencies for building this, which is really great. One gripe, I was talking to somebody about this yesterday. I wish there was a Dart WebRTC package, because then we could use it like on the machine as well. For now, Flutter WebRTC, we have to have Flutter as a dependency. If you want to build a Dart WebRTC package with me, let's do it. One of these days. I'll get to it eventually, maybe. Yeah, do I even need to explain? No, I don't. You all get it. It's a match made in heaven in this scenario. So let's take a little bit of time to talk about this. How we'd architect this in a mobile app. Again, I see Eric right over there. He's going to think this looks very familiar. I really enjoyed the Flutter app architecture suggestions that the Flutter team came up with. And so we've adopted that on my team, and it works brilliantly for building a system where you need to control robots over WebRTC with Flutter. So I won't read everything on here. We'll go through the code in a minute. But yeah, so you're talking to the WebRTC, the robot over the wire, that's in the red. Then we have our robot API client, that's like the gRPC definitions. You have the repository, which establishes the connection, maintains the connection, pulls for data. That emits broadcast streams for the pertinent data that you want, which then the view model subscribes to, notifies listeners with it to rebuild the view. We love our layers as Flutter developers. I think this is pretty straightforward. Also works with whatever technologies you're using inside your Flutter apps. So we all know the Flutter counter app. Whenever I'm talking with the more hardware-minded folks at my company, it's interesting to learn what's hello world in hardware. And one of the first things I did when I joined VM was get LED lights blinking on a board. So that's what we're going to do today as a demo. Yay. This is a really great example, hello world, for hardware. So let's get into it. I'll explain a bit more. So let's talk about the hardware setup. We're going to use a Pi. I'm using a Pi 4 in this case. It has GPIO pins. If you don't know what GPIO pins are, here's an example of a leaflet that explains what they are. But essentially, Some of them always send power, some of them are ground, and then some of them are like GPIO, which means you can like modulate the signal going over them, which you can use for a plethora of controlling hardware. So yeah, that's kind of how we're going from like software to like controlling the actual like ones and zeros or signal that's modulating to like control a motor, or in this case a light. This is like what the wire out's going to look like. It's, again, really simple. You're just going to wire up, complete the circuit to an LED light. We're using a breadboard to do this wiring. Goes through and back to the ground. In this case, I did 4 lights because I'm a masochist and I wanted to show off more things. So let's talk about the software setup. Okay. In this case, so we're using a Flutter app. I'm using our VM Flutter SDK, which has all of the protobuf gRPC definitions, and then we wrap it in like a Dart idiomatic way, because who likes working with generated code? It's horrible. On the hardware, we're running what we call VM server. That's what we were talking about before with the robot. That's what signals to our central server, and that's what's going to allow us to like talk back and forth. That's the other peer, and it's running on the Pi. You can run it on any architecture you want. We support a whole bunch of like industry standard hardware. So we're going to signal, again, we just walked through this, gRPC to a central server. In this case, it's app.vm.com. We're going to say, hey, we want to pair with this robot. In this case, we have API keys. And so there's a lot of security baked in with our setup as well. It's where you can define API keys, give them certain permissions. And then that's how we'll establish the direct connection with it. Let's see, anything else? I could have built this from scratch, or we could have built this from scratch. It's a lot of work. I feel like I've shown you kind of like the underpinnings of it, and you definitely could build it yourself. But you get a lot of benefits to using VM, and we've already built it for you, and it's open source. And everything running on the machine is like free. You don't have to pay for running things on the machine. So yeah. Okay, let's go to the code. Oh boy. There. 1 second. Choose to mirror. Oh, okay. Okay. So first off, we're going to start in the VM Flutter SDK. I'm going to show you the code for dialing over WebRTC. Again, this is all open source. Please go check it out yourselves. As we already talked about, dialing WebRTC is like a whole bunch of handshakes in a row. And in our SDKs, we have it already implemented in Go and a lot of other things. So in some ways, this dial was built to mimic how we built it in Go initially, but I'll walk you through some of the basics. It's hefty. So here you see we're reaching out to that signaling server that we talked about. Oh, thank you. What is this, code for ants? Okay. Hey, okay, is that good? Bigger? We'll go a little bigger. Okay, great. Cool. Okay, so we're in this method called dial WebRTC. We're passing in the address. The dial options is an object that has some other configurations, but it also has like the API keys bundled into it. In this case, you see here, we're calling the signaling server, which is, oh, can I go over? There we go. If you don't override the address, it's going to be app.vm.com, as we talked about. It's going to hit it. We have some things where we're like timing for metrics in here. We dial direct gRPC to that signaling server to get the signaling client, which then we try and connect. Yeah. Here, as we talked about, we're starting to hit ICE servers, starting a timer to see how long it makes to establish the peer connection, and then we're going into hit that peer connection. This is another method. Negotiating handshakes, passing around UUIDs, so on and so forth. I invite you, go check that out some more. Now we're going to jump into the app code. Make this bigger right off the bat. Okay. So, like any good Flutter app, we're going to start off with our main file. In this case, we only have one repository. Other apps are going to be much more complex, but we're just passing it in right from the get-go to a multi-provider, so it's available all throughout this very teeny tiny app. Yeah, I decided to do a Shad CN app for fun. The UI isn't really relevant in this case, but we'll make it kind of cute. Yeah, and then just for kicks and giggles, did a Go router, and that's where we like pass in the repository that we defined. We context.read that into the view model and into the screen in that case. So let's go look at that repository code. Again, this repository establishes the connection and polls for data from the robot. In this case, we're polling, are the lights on or not? And then we're passing that down. We're also polling for if it's connected and so on and so forth. So establishing some screens that we're going to pass in. And this is where we're connecting, starting our polling, fetching the status. We also have a camera here. I'm going to start a build iPhone 16 because we are short on time. Be sure to clean up your streams when you're done. In the polling, we're just using those gRPC APIs that we defined to say like, hey, get the status of this pin. And I've defined like what's the red pin, green pin, so forth. We get that, and then we emit it down to that. We also can update the values. So we're showing that. The view model, in this case, is really simple because we only have one repository. Typically, view models would have multiple. So it's mainly just a pass-through for everything. We're listening to those streams, notifying the listeners when we get a new value. The view is going to show a loading state if it's not connected. Otherwise, it's going to show a bunch of buttons and a camera stream, and then the buttons, and show them lit or not. So I believe that's running. Hey, okay. Is that teeny tiny? Let's make this bigger. That's pretty good. Okay, so let's connect to right here. If you can see it on this chair, I have a little robot. Again, this is a Raspberry Pi-based device. The internet here is not great, so it takes a second. But there we go. We have established a WebRTC connection within a few seconds, even on this not great Wi-Fi. And we see it right here. Right here. We have a webcam that we're streaming. And then we have the 4 lights. And look, it's live. You see my finger in real life. Let's press some buttons. We're going to turn on these lights. One by one, they all work. You can see them here too. The webcam serves like dual purposes because I knew you wouldn't be able to see that very well. And yeah, you can go crazy on these. You can like make the light flicker if the Wi-Fi permits. It will try and keep up. We're firing and forgetting these commands, and we're just assuming if it doesn't return an error, then it was successful. Polling, I'm polling once a second to get the status, so I could actually. See, how do I want to do this? I have the app also running here on my personal phone. So like just for kicks and giggles, I'm going to also connect to it and then change the light so you see it update. Yeah. So you see, even if it gets changed from somebody else telling it to change, you're polling, you'll get that data freshly from the robot server. So this is cool, and I could be fooling you right now. I'm right here. This robot's right here. I don't know, like, could be Bluetooth. Actually, it probably made a direct connection to it instead of going over WebRTC. So to further demonstrate, on my desk in the Upper West Side, on the other side of Manhattan, I set up this same exact rig. And let's connect to it. And I will show you that I'm not fooling you. And there we are with some familiar friends. We've established in about the same amount of time a direct WebRTC, or a peer-to-peer connection with a Raspberry Pi over WebRTC, and we can command it with about the same amount of latency as we did, even if it was right here. So I can turn all these lights on and off. It's getting them. I could connect to it from my phone and turn them all off. That's controlling robots over WebRTC. Thank you. Let's see. If I can get back to my slides, I will show you that I asked for questions, but I don't know where those went. Boop, 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 boop. Where did those go? Oh, there it is. Alrighty. Okay. Very briefly, slideshow present. Hold up. There we go. Okay. Just to review, this is what we did. Connected to that over WebRTC. We have a central server that we talk to establish that WebRTC connection. I'm going to try one more thing, actually, before we go. We'll see if... Oh, the demo gods are smiling upon me. So to further display the... Oh. This might not work as well, but let's try it. I brought another toy of mine that is slightly, ever so slightly more advanced than the light. There we go. Oh, the camera feed went out. Oh, Wi-Fi is too slow. Okay, I'll try it again later. Okay. Thank you. Yeah, thank you. Thank you. Any questions? Yes. And then talk loud, I'll repeat the question. Or let's see, Jake, does the mic work? It was having problems yesterday. They're going to try it out. If not, yell loud.
All right. Can you hear me?
Yes, I can hear you.
All right. Do you have any pointers on things that we have to be careful with when connection might switch? Like if you're going from Wi-Fi to mobile, what happens and how can we solve that?
Yes. Great question. That is definitely a thing you have to consider. It will break the WebRTC connection. So what you do is you monitor if it breaks and then just reestablish connection. It can break for all sorts of reasons. But yeah, you just are monitoring it probably in the repository. Also our SDK kind of manages that reconnection, but yeah, I built a robot, like a home hack project that buzzes me into my own apartment. And when I like go through after buzzing in, I have to remember to like unbuzz it really quickly because I get on my home Wi-Fi, walking in, and it loses the connection, and then it buzzes for like 30 seconds, and I'm sure it's really annoying. But so yeah, you have to be careful of that. You just pull, have a heartbeat that's checking that connection. If it breaks, reestablish it. That will handle a lot of your edge cases for you.
All right, thanks.
Mm-hmm. Any other questions?
This isn't directly related to what you presented, but I'm curious if you guys have played with any on-device LLMs like Gemini Nano to try and use AI to control robots from a Flutter app.
Yes.
Sounds fun.
So not from like a Flutter app specifically, but I view that as like an abstraction layer. Is like with our platform or with this kind of like WebRTC gRPC setup, the client could be a web app, could be a Flutter app, whatever. But we have put LLMs like on machine, and there's some demos we have where you're like having a conversation with it, or it's like pretending to be somebody and you have to like guess who it is, and stuff like that. So that's really common. We've built some like security apps where it's like an Orange Jetson, like a bigger Linux box that's running computer vision on cameras. And then those are doing detections and then like send a push notification when they see somebody, and it like sends you their face and stuff like that. So those are the kind of models we've been interacting with. You can manage and deploy those kinds of models using our platform onto the machines, and then it would be really easy to like interact with them as a service like running on the machine.
Very cool. Thank you.
Yeah. Good question. Any other questions? Okay, I'm going to show you. Let's see. It's working now. We'll see how well it works. Oh, come on. No. Oh, it's not working. It's not driving. Do I know why? No, I don't know why. Okay, this is supposed to drive around. I was trying to like squeeze it in, but it's like the hardware's busted. Cool. If there's no other questions, right? Thank you so much. All the code for this, like this little sample app, open source. I have it on 2 phones up here if you want to come like play around with it. I have a bunch of codes, slides, link. Feel free to email me if you have more questions. Yeah. Thank you. Thanks for coming. Thanks for listening.